Hi, this is Amy Lewis. This is Engineers Unplugged. Hi, this is Amy Lewis, and we're back with another episode of Engineers Unplugged. We've got Damian and Frank, and they're going to be answering, there are no VHS aficionados. What does this mean? Damian, take it away.
I have no idea what it means. However, thinking about it, it seems to me that as technology changes, the new thing tends to replace the old thing, but not always.
Yeah.
Am I correct?
Yeah, I think you're correct. So when we talk about technology in the broader sense of words,
Right.
there's a lot of technology that tend to replace it or are announced to replace the old one, but in general, it actually isn't. For example, the CD didn't replace vinyl, right? There's still a lot of people who actually like to listen to vinyl because it has that distinguished sound, right?
Warmth. Yes.
Yes, exactly. Now, the only thing what I could come up with is that the DVD replaced the VHS. There's nobody out there, or at least I don't know about, that says, no, don't give me that Blu-ray disc or that DVD disc. I like to have my image grainy. I like to get my VHS tape or my VHS fix in order, right?
I always like to be kind and rewind. Yes.
Yes, oh, that's another one, right? So if that's the case, right, and if you say that, if you look at all the technologies that tend to replace it, it's not, basically it's not true, right? So why does the community, especially in the virtualization, why do they actually always think that, hey, the newest thing is going to replace everything that's already in the data center? For example, storage arrays, right? So I believe that a centralized storage array still makes sense in everyday data centers. There are still a lot of good things about storage arrays, right? You have your centralized management, you have your data capacity that's in one place. However, if you look at the new technology about accelerating performance on storage, we see a lot of server-side flash technology, something like Linux Data, something like vSphere Flash Read Cache, right? Now, these things do not replace storage arrays, they basically enhance a specific feature, like performance. Right? You have when you buy an array, you're buying an array for data service, you're buying an array for capacity, but you're implementing Linux FEP, for example, for your I/O performance, right? So what we think is that the new technology is going to basically not do a rip and replace, but use a performance layer and a capacity layer. So it's going to, what's a good English word for it?
Auto tiering maybe? Or application-specific storage?
Well, I'm more like maybe I can draw it out.
Yeah, absolutely.
So could you?
Yes.
So when you have your array, you have like capacity, right?
Sorry. So they want you to hold this.
Oh.
Because I'm blocking the
Sorry.
line. Is that all right?
This is a little bit. Okay, so you have your ESX host. And what we basically do, we're going to separate the capacity from the performance. So here you have your flash. I hope you can read this because I'm going like crazy. This is going to be your flash, your performance layer.
Right.
And this is going to be your capacity layer. So this will provide your VHS fix in some way, and this will provide your true scale-out performance. This can be FEP, this can be another acceleration platform, of course, right? So if you need to have more performance in a traditional array, you either do a rip and replace of your array, or you try to basically expand it more, do another shelf, or do another thing. Usually most customers, they do they just add a new array in their data center, right?
Yes.
Now we say, no, keep your performance in your performance tier, in your compute tier, because you have memory and CPU, right? The flash layer, the clustered flash layer, will give you the storage performance. If you need virtual machines, if you're going to run more virtual machines, just add another host. Add that host with CPU, memory, and flash. Right. So this layer, ESX for your CPU and your memory, and this is flash.
Gotcha. Okay.
Yeah.
So using this sort of concept, do you have the ability to specify which VMs would go to that flash, or is it just accelerating all of the VM workloads?
Well, this is the cool part, right? So you have virtual machines. Some virtual machines need to have that performance increase.
Right, yeah.
Right?
Based
so
on the application.
Yeah.
Yes.
So these virtual machines that are critical to your environment, you're going to accelerate. So you're going to say, make use of this level, of the I/O performance level, right? Or basically you're running it into your performance tier now. Mm-hmm. However, this is the cool part, because these I/Os and these operations tend to remain inside the performance layer. It's not hitting your capacity layer at all, right? So what happens is the other virtual machines that are not using that layer on the flash layer is actually benefiting from the reduced amount of I/Os hitting your capacity layer and your, well, secondary tier of performance.
Okay,
right?
So how does this approach, well, what's the difference between this approach and actually having storage with auto-tiering within the storage itself?
I think that's pure physics.
Okay.
Right? So what you're doing with flash at if you put it into an array, you're actually placing it way, way, way away from the application itself. So a low latency device, you're going to place it behind a relatively high latency network, shared network. So it's like a funnel, right? More ESX host into a single capacity, or like I call it a capacity tier, right? So the pure physics side of it is basically distance. So it cannot ever meet the same performance levels as putting it close to the application as possible.
Well, cool.
Yep.
Well, thank you. I think this is a great topic, and it's quite informative. Thank you. Thank you, Frank. Thank you, Amy.
Just a little reminder that it's unicorn time. Great information. I think you had a unicorn challenge for me. You were going to explain a technical unicorn. Is that correct?
Well, the first challenge you gave me was draw a unicorn, right? So I said a couple of times on Twitter, real men draw block diagrams, right? So I'm going to try to do a unicorn in a block diagram situation. So, head, no, let's do that. Head, unicorn, neck, body. It's not a pretty unicorn, but... And then we have detail. Right? Now, I came to think of another thing, because we're engineering unplugged. There's a rumor that unicorns produce rainbows, right? How does it produce rainbows? We think, critics data think this is actually a prism. This is like, well, I think it goes like, yes, this is like an optical fiber. Here's the sun, hits the light, goes through the fiber channel, produces a rainbow.
This is why you don't ask engineers challenges, because they'll solve them and outsmart you every time. Just a little tip for everybody out there. So thank you, Frank. Thank you, Damian. And we'll see you next time on Engineers Unplugged.